This is the post-launch news conference for Aquarius SAC-D, launched successfully this morning from NASA's Space Launch Complex 2 at Vandenberg Air Force Base in California. And here to discuss the success of our mission today is Chuck Gay, the Deputy Associate Administrator for the NASA Science Mission Directorate in Washington; Hector Timmerman, the Foreign Minister of Argentina, Buenos Aires; Michael Freilich, the NASA Earth Science Division Director from NASA headquarters; and Conrado Varoro, the CONAI Executive and Technical Director from Buenos Aires. And we'll begin first with Chuck Gay. Chuck?
Thank you, George. Well, first, I think I speak for the entire panel when I say we're extremely pleased to be here this morning. It's been a great day so far. On behalf of NASA, I would first like to congratulate the entire team of international professionals who have worked so hard to accomplish what they have to this point for this very, very important Earth science mission. The mission itself is certainly notable for its scientific objectives, which we've heard about in the pre-launch press briefings, but it's also extremely notable in its demonstration of what can be accomplished with international partnerships, the value of those partnerships, and how they can be and should be performed. I can't tell you how proud I am of the entire team. You know, I've watched them over the past, almost 10 years work together, overcome obstacles and hardships together. I've seen them become friends, and I've seen them become a family. And I think these, the bonds that have been established during this mission have, in some way, made the Earth a little bit smaller place for us all. So, back to you, George, and we'll let the other panel members talk about the mission.
All right, thank you, Chuck. And now to Hector Timmerman, the Foreign Minister of Argentina from Buenos Aires. Hector?
Thank you very much. And as I share the happiness and about a successful launch of an Argentinian space mission satellite, and in cooperation with such an important organization as NASA. But let me tell you that how proud we are, the Argentinians, of this achievement, thinking that 10 years ago, Argentina's economy, social and political fabric collapsed. And since that time, we have been coming out with a big effort of our people, and the government didn't ever forget the importance of science. And so we bet on our scientists, and they were able to develop an important instrument to search the Earth and to analyze the changes that we are witnessing, both in the seas and in the land. And so my congratulations to all the scientists from Argentina, the technicians, and the cooperation from other countries. Argentina sees the space policy as an international part of our international cooperation. We do this for civilian use. We do this to advance the well-being of our people and the people of Latin America and everybody else. And so it's part of our cooperation with other nations, and we hope that in the future we will see more of these activities together with you at the NASA and with other countries in Latin America and in Europe. Thank you very much.
Thank you, Hector. Now, Michael Freilich, the NASA Earth Science Division Director at NASA headquarters. Michael?
Thank you very much, George. This is obviously a great day for Argentina and CONAI, a great day for the U.S. and NASA, and a great day for all of our other international collaborators on this mission, and it's a great day for science. In the U.S., at least, June is the month for graduations, and with the successful launch of SAC-D Aquarius today, I'm reminded that this is like a commencement. It marks the end of a long period of learning, of bonding, of collaborating between the teams from all of these nations to gain the knowledge that was required and to implement this great mission. And it marks the start of advancing science in ways that we have not been able to before. Aquarius SAC-D is going to elucidate aspects of the water cycle, the exchanges of water between the oceans and the atmosphere and the lands. It's going to tell us a bit about how the ocean circulates and therefore how the ocean contributes to moving heat around from low latitudes to high latitudes, making this Earth more habitable than it otherwise would. And Aquarius SAC-D is going to be making measurements in places that have never had measurements made before, and it will be making them every week for years and years. This is going to be a great mission. It has been a superb collaboration that has brought our countries together and our communities together, and I think you're going to be hearing a lot about SAC-D Aquarius in the years to come. Thank you,
Michael.
George.
And now to Conrado Veroto, the CANAI Executive and Technical Director from Buenos Aires. Conrado?
Thank you, George. A couple of days ago, I mentioned to some young people that we are coming from Argentina just to watch Aquarius SAC-D going into orbit, that it could be they will see almost nothing since it was expected heavy fog. The answer was, what matter is the emotion to be there. And certainly it is the emotion of knowing that in just a few minutes we may be fully successful, or it could be that we end feeling that years of hard work have been wasted. I'm sure that our friends from the States, Canada, Italy, France, and Brazil do share the same feelings. This is time that the people from Goddard and JPL will proudly watch their Aquarius instrument. The Italian Space Agency, their Rosa instrument. The French Space Agency, their Carmen instrument. The Canadian Institute of Optics, their balometer in the infrared camera. And the INPE from Brazil, the results of their work on the environmental tests. And at home in Argentina, so many people from the National Science and Technology System will be watching the result of their works, such as the National Atomic Commission with the solar panels, our Radio Astronomy Institute and our Optic Institute of the National Research Council with microwave radiometer, the infrared camera, the University of La Plata and the Technology University with other instruments, and the main developer of the space platform, INVAP. And many other people from other research centers and universities as well as from the industry, because it is a national project. We are very grateful to all of them. At this time, we are very happy. We know that Aquarius SAC-D is in orbit, alive, that it will deliver data. It was worth the effort. Now Aquarius SAC-D is moving towards a new, fascinating, productive stage. It will be the responsibility of our people at the Teófilo Tabanera Center in Córdoba to manage the mission, to ensure that the satellite will deliver data in a timely and appropriate way. And it will be the responsibility of the science team selected jointly by our Ministry of Science and Technology, NASA and CONAE, to use their imagination to find new and fascinating applications for the Aquarius SAC-D data. New and fascinating ways to help to a better understanding of the Earth environment, to contribute to a better knowledge of the essential climate variable to help our health, to save lives. I'm not a poet, but today I wish I could write a poem of life, a poem of love, a poem of happiness. And looking back on my life, I will be always grateful to my parents for taking me to Argentina, a country of opportunities, a country where you can have a dream and it will give you the opportunity to convert it to reality. Let's today give our thanks to God for all these blessings. Thank you.
Thank you, Mr. Veroto. We'll take questions now. Please give your name and affiliation when the microphone comes to you. And we'll start right here in the front with Nora.
Nora Wallace, Santa Barbara News Press. Minister Timmerman, can you explain to us in the U.S. media how important this mission is for just people, regular people in Argentina, not the media that are here and not the scientists, but your average person in Argentina?
Well, let me tell you that everybody in Argentina has been following the launch of this satellite through public television, through all other media. The president was present during the transmission. Children from all the schools are going to be receiving the information from the satellite, so it's something that is not only a success or a victory or something important for the scientists, it's important for the whole country. It's very important to feel how proud we are of something that sometimes is very difficult to understand, but that we know somewhere in our heart that this is a triumph of a bet that we made many years ago in Argentina. As Dr. Barotto said, that there are dreams that are worth following.
All right, we have a question right in the back. There you go.
Ventura County Star, just a basic cost question. How much did the mission cost?
400 million was it?
To whom?
That's the only figure we can give.
Yeah, the total mission cost is approximately $400 million.
All right, I think we have a question right here.
Yeah, my name is Adrian Paenza, and I work for Channel 7, the public TV in Argentina. It doesn't go unnoticed for us that naturally the United States could have built the satellite themselves. You guys have the scientists to do it. However, you pick Argentina, and for us it's obviously a reason to be proud. But instead of me saying that we are proud, I would like to ask either Michael or you, why did you pick Argentina? What made you say, okay, what is the main reason? We want you guys to be our partners.
Well, sir, and Mike can add to this, but certainly there is a history of partnership with Argentina from the earlier missions, and teaming and partnering with Argentina and other international organizations allows us to accomplish more than we can alone, just from the simple economics. But Argentina has a proven track record with in partnering with NASA, and we were pleased and proud to be associated with Argentina for SAC-D Aquarius.
Yeah, Chuck got the absolute essentials of the answer. Let me just say a few other things. Argentina and our past collaborations with them have really helped to advance our understanding of the Earth. And understanding the Earth as an integrated, complex system is way too hard for any single nation, any single agency. But we need to have partners who are willing to truly collaborate, not simply take orders or give orders, who have vision, who have sustained effort, and are willing to attack the challenges that arise during the many years that these missions are under development. And Argentina has proven time and time again with NASA and in other ways that the spirit of that nation, as well as the competence of your scientists, is there. And NASA is indeed proud to be a collaborator with Argentina and the other international collaborators on this mission.
Hi, good morning. This is Nora Barr from La Nación in Buenos Aires. Does the success of this mission, up to now at least, let you think about a new mission, a new collaboration?
Okay. I can answer it in a very simple way. Many years ago, I have a meeting with the NASA, at that time NASA administrator, and we said, okay, SAC-A, SAC-B, SAC-C. Well, we had to follow up to Zeta, and then when we arrived there, we have still the Greek alphabet.
right here in the front.
Al Stoller, KVMR-FM. As an amateur astronomer, I'm very concerned about light pollution, also interested in the amount of energy that we beam up out into space. I'm curious if you could tell me something about the high sensitivity camera and the urban light investigation.
Well, the high sensitivity camera actually is already flying in SAC-D, and besides to do studies on lighting and snow cover, there are many things that we use that camera for. Also, it has another reason to be there, and is related to a problem that we have in Argentina, which is fishery. And we are using that camera just to catch those people who don't behave well.
Any additional questions? All right. All right, let's go back here. Hey, wait just a second for the microphone for you.
From what I understand, this satellite is supposed to be able to collect data that's been, for the past 110, 15, 25 years, been collected by buoys and people and ships and stuff like that. With this, I'm assuming this satellite is going to collect in a more accurate and thorough way and collect in areas that you haven't been able to do before. Is it going to be useful in terms of comparing what the salinity levels have been in the past, or is it just from this point on monitoring the salinity points in the water? Since the older methods might not be as accurate.
I'll take a shot at that. It's an extremely insightful and thoughtful question. As the questioner stated, since the dawn of civilization, salinity measurements have been made rather sporadically at points and intermittently in time with varying accuracies. What Aquarius SAC-D will be doing will be making global measurements frequently with high precision, high accuracy, and high stability. There are places in the ocean, particularly in the northern hemisphere, where we have almost enough salinity measurements in the past to be able to continue a time series, as you pointed out, with Aquarius SAC-D. However, over vast reaches of the Earth's ocean, especially in the southern hemisphere and the southern oceans, this will be first measurements. So it's a combination of extending our knowledge and improving those measurements in some areas where we already have fairly reasonable measurements, but extending excellent measurements to areas that we've never measured before.
We can take additional questions if there are any.
Hi, Lucas Viano, La Voz del Interior de Córdoba, Argentina. How was the contact with the center in Falda del Carmen in Córdoba, and it's for Baroto? And which was the first word when you contact with this center? What was the words they said and you say?
Actually, the first time that we got in contact with them was through the president. She was just as the minister of our Minister of Foreign Affairs says. She was so proud. She wanted to talk immediately after the launch. So we talked with them immediately after the launch. And what was very important is that at Córdoba there were kids from our 2MP program. As a nation, we do a very big outreach effort to have space information, not only for scientists, but not only for production, but for kids. And those kids that were there belong to a school, one of those, we have many of them, that today are using space information delivered from satellite like this for their common days or duties.
Any follow-ups?
Ariel Wessler, KSBY TV. My question is, I understand that the salinity measurements from space, this is a first for NASA. Can you speak to why do this now and kind of what brought on the importance of this mission to take salt measurements from space?
Certainly. As I alluded to in my brief remarks, the key to understanding the Earth is not simply to understand individual processes, but rather to understand their linkages. And salinity, surface salinity in the ocean provides linkages and understanding of a number of different cycles in the Earth. If we want to understand the water cycle of the Earth, we have to understand things like evaporation and precipitation, that is the water moving from the land and the ocean to the atmosphere and coming from the atmosphere back to there, back to the ocean. And when you rain on the ocean, you change its salinity. The surface salinity becomes less. When you evaporate water from the ocean, you change its salinity. The surface salinity becomes greater. When you freeze water into ice, the ice rejects the brine, and the salinity of the surrounding ocean increases. So the point of making those measurements today is that they help us to elucidate so many different aspects of the coupled processes that define the Earth as a system. Furthermore, the deep circulation of the ocean is driven by density differences. Heavy water sinks, lighter water floats, and the salinity content of the deep ocean, of the subsurface ocean, is a big part of determining the density of those waters. So if we are to understand subsurface currents, we need to understand surface salinity, because it's at the surface where the imprint of salinity is placed on the water. So it really ties together a lot of things. It's an extremely timely mission.
But as far as the technology, this is something we couldn't have done 5 years ago or 10 years ago?
The microwave L-band radiometer plus the scatterometer that is used in the Aquarius instrument are far and away the most accurate and precise and stable instruments of their type that have ever been flown in space. This really could not have been done 10 years ago.
Thank you.
Any further questions? We have one over here on the left.
Hello, thank you for this opportunity. My name is Melissa Cabo. I'm with the news agency of Argentina, Telam. For Mr. Barotto and Minister Timmerman, I would like to know what did you feel while the launch of the satellite? And for you, Mr. Gay and Mr. Michael, having in mind that the past two launches weren't successful, I would like to know what did you feel this time?
Well, somebody has to start. You know, I was watching two scenes at the same time. One was the satellite going up, and the other one was Mr. Barotto embracing a lady and crying. And that, no, to see both things, I was able to better understand the significance of this from a human point of view. I mean, then I saw the Americans and the Argentinians at the control center embracing themselves. Sometimes for us, lay people, it's very difficult to understand scientific development, but I can understand human feelings. And then I saw how important is the cooperation, not only from a scientific point of view, but also from a human point of view. And here I saw humankind working at its best.
I would just
fully agree with you.
Yeah, I would just say certainly we were thrilled and excited for every launch, we work very hard to ensure the best we can that we're going to have a successful launch opportunity. But it's a risky business. I mean, so many things can go wrong, and sometimes they do. And we redouble our efforts, every time, just to try to look at every little detail to make sure nothing is missed. And despite all that effort, we still kind of hold your breath, while you're going through the various events during launch. And I don't, no one was really, really comfortable until we saw the separation of the SAC-D Aquarius from the launch vehicle, saw the solar arrays open up, and got telemetry from the spacecraft saying that we had positive power on the spacecraft. So it took a long time. I mean, in degrees, we were getting more and more comfortable and excited, but we know it's not over until we get to the point where the spacecraft is flying by itself, separated from the launch vehicle. And I think we all breathed a sigh of relief, and we're ready to come here and tell you all how excited we were about this mission.
I'll encapsulate my feelings with 4 words, 3 of which have been said before. Certainly relief and joy. Relief that we got such a wonderful ride to orbit from the Delta II on which SAC-D Aquarius was launched. Joy, obviously, that the spacecraft is working so well from the beginning. Anticipation, as a scientist, as an oceanographer, indeed, anticipation of the great things that this mission is going to be accomplishing, and very personally, hunger. It's been a couple of years since I have wanted to eat after a launch, and I wanted to eat this morning after the launch.
And Conrado, did you have any comments to make?
Well, no, I mean, just the minister says everything, so.
Okay. All right. Well, in that event, that is going to conclude our post-launch news conference this morning and our coverage of the Aquarius SAC-D launch. The next event, we hope, will be an exciting briefing about the science that Aquarius SAC-D has delivered. Thank you very much.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of Aquarius and the SAC-D Observatory on an international mission to study Earth's salty sea.